Hello everyone! In this video I wanted to show you the latest features available in PCG Painter version 1.5.2 and especially how to create your own custom PCG Painter actor. Let's start by creating a new empty level, and keep in mind that by default the PCG Painter only paints static objects. So let's start by selecting the floor and set it to static. Then we will create a folder to save our blueprint. And in this folder, what you want to do is to create a new blueprint of type PCGPainterActor. You give it a name. And if you open the blueprint, you can see it already has an icon that you can customize if you want, and a PCG component. On this PCG component, you can see that you already have a graph selected, which is a Painter Graph prepare points. So this is where the root points and the points scattered around the root point are created. What you want to do is to create your own PCG graph to consume those points, root and scattered. And this graph is the PCG Graph processor here. So let's create a new PCG graph. And you set it as a PCG Graph processor here. You compile and save your blueprint. Now, if you go to Scriptable Tools, PCG Painter, you can see your custom actor is available here, My Custom PCG. And if you select it and start to paint, nothing happens. This is because this processor here does nothing for now. But if you click on Show Root Points and Scatter Points, you can see that the root and scatter points were already created. So let's do some things inside this graph. So you open My Custom PCG Graph, and all the points generated by the PCG Painter will be sent to the first input, this in pin. So let's already start by casting it to point, because we know the PCG Painter produces points. And let's start by adding a debug node. You can see now you have a visual representation of your root and scattered point. You can inspect the data here to see what is available as attribute. And if you go to this list here, you can see all the PCG Painter attributes start with double underscores. So you have the brush custom data, brush radius, impact normal, and so on. So let's use first the root points alone. So what you can do is to filter the input points by this attribute, root point. So if I add a point filter here, and let's disconnect that. And if you say that root point is equal to an integer 1, sorry. This is a root point, the root point, and those are the scattered points. Let's check that with the debug node. You can see that yes, you have root points here and scatter point here. So let's just spawn static meshes on the root point. And we're going to add a mesh here, basic cone for instance. So now you have these red cones on the root point. If I duplicate this node, You can see now you have also those cones on the scattered point. Let's change this model for the basic cube. Add some randomness in the points rotation. And let's do scale as well. Okay, so now you have a basic custom graph which can be applied and painted on your 3D object. Now, the good thing about custom actor is also the ability to expose variables and use those variables inside your graph directly. So let's start by creating a float and call it ratio. You set it as a public variable. You compile, you save. Set is a default value at 0.5 for instance. And now this variable is set on the actor directly. So you can access it using getActor property. And the property name is ratio. Let's set it as an attribute called ratio. And now if, for instance, you use the select point node, which basically reduces the number of points according to a ratio, you can set the ratio which comes from the actor as the ratio input of the select points node. And now if you go to your actor, you can see that you have ratio parameters that you can change to change the number of points used by the graph. What you can do also is to set a category of this on this variable, and if you set it to Painter parameters here as a category, and if you compile and save, if you open the PCG Painter again, you can see that the parameter ratio, the variable ratio, is available when you click on Show Instance Parameter directly inside the PCG Painter UI. So you can change the value here directly. So you can expose as many variables as you want. For instance, you can let's expose primary static mesh, or let's call it root points static mesh. The type would be static mesh, object reference, set it as public, compile, save, and let's use as a default value the same static mesh as before. You compile, save. So now, just as a verification, if you open the PCG Painter again and show instance parameter, you can see that the root point static mesh is not available because it's not in the right category. So if you select the variables and set it as Painter parameters, you compile, save, and now if you open the PCG Painter again, you can see the root point static mesh is available. So same thing, let's use getActor property and get the reference of the static mesh we want to spawn on the root points. And we have to tweak a bit the static mesh spawner in order to spawn this mesh which come out of this attribute. Let's add an attribute here, and we call it static mesh. So if you inspect the node, the graph, sorry, you can see now you have static mesh attribute, which is set to the basic cone mesh. We plug that into the static mesh spawner, and instead of using the PCG mesh selector weighted, you can use by attribute set the attribute name to static mesh, save the graph, and now you can see the red cone has spawned just as before. But the thing is, now it's exposed here. So if you update this parameter here, you can see that you can change the mesh directly from the PCG Painter. So this is for the exposed variable on your custom actor. But you can also use more attributes than that. For instance, if we inspect the graph again, you can see that you have the brush custom data, which is integer set from 0 to 9 and by default -1. -1 means there is no custom data applied to those points. So you can see here it's all set to -1. But if I paint points with a different custom data value, it will be set accordingly here. So custom data is this list of buttons here. So if I click on 0, you can see it's now turned green. And if I paint points with this, you can see that the latest point will have 0 as brush custom data. So now with that, you can do things, change the behavior of your graph. So let's add a point filter again. And let's say if the brush custom data is equal to integer 0, then do something, otherwise do something else. So let's say if we don't have the custom data set to 0, we proceed the regular graph. So you can see the points with the 0 as custom data are now gone because nothing happened here. So let's spawn another mesh. You can see now it's back. And if I change the mesh here for the blue cylinder, for instance, now you can see at the points with custom data 0 spawn blue cylinder. If I switch off the custom data, so if I click again on the entry, so now it's not selected anymore, it's the regular graph which is applied. If you paint over a point, an existing point with a different custom data, the painter will update the custom data on those points. So like for instance here, you can see it updated the custom data which was -1, so nothing before, to 0 now. So this is for custom data. Again, let's inspect those points to see what we can do otherwise. So you can see also you have the brush stroke ID. So the brush stroke ID is an integer which is different every stroke you paint. So let's inspect that brush stroke ID. So you can see it starts at 0, and for all the points in the first stroke, it's set to 0. Then 1, then 2, and so on, 3, and so on. So you can use that to customize your graph as well. Let's say, for instance, that I want to change the behavior of the graph every 2 strokes. So if I, again, let's do a modulo first. So I create a new attribute of value 2. And let's say the brush stroke ID modulo 2, we output the result as is even attribute. And if I filter the point again, according to this attribute, if I say is even equals to 0, let's execute the regular graph. Otherwise, do something else. Let's do another static mesh spawning for that. Let's change the mesh for, what do we have? This yellow torus. And now you can see every 2 brush strokes, sorry, it spawns those yellow torus. So let's verify that. Torus, regular graph, torus, regular graph. So those are the feature which is available for you to customize your graph. You have other attributes to explore. If you want to create rules according to normals, for instance, if you want to spawn certain meshes on certain orientation and stuff like that, do some stuff with brush radius. And you also have actor reference and physical material reference, which is attributes which can help you to spawn different meshes on different type of actor. So it's these 2 attributes here. So that's it for this video. And I hope you enjoy the tool and you can start playing with custom graphs. Thanks for watching.